In this video, we're going to cover some examples of how to do basic probabilities given different types of outcomes that we're interested in finding. So in here, we're looking at a fair six-sided die. The reason they say fair is they want us to understand that means that every probability has an equally likely chance of occurring. Okay, so if it's fair, then the sample space is going to be the numbers 1 through 6. So here I'm going to list that over here. 1, 2, 3, 4, 5, 6. So those are all of the outcomes possible. And they want us to identify what's in each subset and find its probability. So looking at the first event T, and that is that we get an outcome of 2. So that means that there's literally one outcome possible, and it's 2. And the probability of getting 2 would be 1 out of 6. Looking at the sample space, there's only one option for getting 2 out of 6 total. All right. So the event A, that the outcome is an even number, well, that would be 2, 4, and 6 would satisfy those possibilities. And the probability of that happening would be 3 out of 6, or 1/2, or 0.5, or if you feel like you can write 50%, that would be fine too. B would be an outcome less than 4. So strictly less than 4. 4 would not be included in that. And that would then be 1, 2, and 3 would qualify for being less than 4. And the probability of that is actually 3 out of 6 again. There's 3 possibilities that B can occur out of 6 total possibilities, which is 1/2 or 0.5. All right, the complement of A. So they use that terminology A prime to represent that. And it would then be, since A is the even numbers, it would be the odd numbers. So that would be 1, 3, and 5. And the probability of its complement is actually going to be 3 out of 6 again. I'm seeing a theme. All right. Now here's where it gets interesting. A given B. So we're wanting to know the probability that A is going to happen, knowing that we're looking at the outcomes in B. So B is restricting our sample space. We're no longer looking at 1 through 6. Now we're looking at 1, 2, and 3. So of those 3, how could A possibly happen? Well, the answer is you would have to roll a 2 in order for that to happen. So we would have to get a 2 out of these 3 outcomes. So there's only one way A can happen. Oops, let me write the notation. So this is the probability. Well, here, the set A given B, actually, that would be interesting to write. A given B. Okay, that's how we write that. Would only be 2. There's only one outcome that can happen that satisfies A that is contained in B. And the probability of that happening is 1 out of 3. And that would be the lowest possible way we could write that. You could write 3, 3. I'd round it. Don't bother writing a bar when you're talking about probabilities. Okay, B given A, the reverse direction now. So now we're saying that we want to know the probability we'll get a 1, 2, or 3, knowing that A is what has happened. We're looking at even numbers only. So again, the only outcome that can work is 2. And again, then, the probability that we'll get a 2 is 1 out of 3 when we're looking at seeing if we get a 2 when we know we're looking at the even numbers given by A. A and B. Okay, so for A and B to occur, that means we would have either an even number or a number less than 3. So it has to be in both. And again, there's only one possibility. That's 2. But now we're not restricted to the subset we're looking at. I'm sorry, the sample space we're looking at. So now we're back to looking at our 6 possibilities, 1, 2, 3, 4, 5, 6. And there's 1 out of, 6, because 2 is the only chance of that occurring. And I realized I didn't put the decimal earlier. So you could have write 0.17. That would be the rounded version of that decimal. I didn't do that earlier. So 0.17, put a little box around it. Be consistent. All right. A or B. Okay, so for A or B, now we're looking at numbers that are in both. Here, let me zoom out a bit so I can see my A and B. Okay, so they need to be in both. So numbers that are even and numbers that are 1 through 3. So I'm going to list them and I'm going to put them in order. So I will start with 1, 2, 3, and then I'm going to add 4 and 6. It just looks a little neater that way. So the probability of this, I'm going to run out of space, is 5 out of 6. So again, we're back to being out of 6 because we're not looking at a given probability. Or if you want to write that as a decimal, it would be 0.83. I'll try to squeeze that in. Yes, I did it. All right. Okay, now we're looking at A or B complements. So now we need to find B complements. Let me do that really quick. So B complement are all the numbers not in B left over in the sample space. So since B is 1, 2, and 3, B complement would be 4, 5, and 6. All the other numbers in the sample space. So A or B complement then would be all of the numbers in A and all of the numbers in B complement combined. And again, we don't write repetition. So even though 4 is in both of them and 6 is in both of them, I'm not going to write that twice. Okay, so I'm going to write in an order though. So 2, 4, 5, 6. There we go. So the probability of A or B complement is 4 out of 6, which is 2/3, or 0.67. Squeezing that in there. Okay, so look at them getting fun. N is a prime number. So prime numbers, those are numbers that are only divisible by 1 or itself. And 1 does not qualify because being divisible by 1 or itself is the same statement. So the first prime number is actually 2 because 2 is only divisible by 1 or itself. 3 actually works. 4 does not because 4 is divisible by 2. 5 works. 6 does not. It's divisible by 2 and 3. So there we go. Those are all the prime numbers. And the probability of that is 3 out of 6 or 1/2. Oops. Putting the decimal in the wrong place. All right. And now we're interested. I'm going to zoom back in again. Make it a little easier to see. Or write on, I should say. Oops. Oops, oops, oops. Okay. I accidentally touched the screen. And now let me fix it. Hold on. There we go. Okay. Stop being mad at me. There we go. Yay. Okay. The event I is an outcome of 7. So that would be, again, a singular number of 7, which would be impossible because we don't have a 7 in this set. So when that happens, we were going to put the empty set. Now, there's a couple ways to write it. This symbol means the empty set, but you could also, some people write it with empty brackets, which is what I was going to do first. But I think I'll show you the symbol. So this is the most common way, the circle with the line through it. And the probability of this happening is 0. It's impossible. It can't happen. All right. So that would be how we would answer when we can't have something occur. All right, let's look at this example here. So they've given us a little table of information. They've looked at a sample of 100 individuals, and they've broken them up by right-handed, left-handed, and male and female. All right. So they told us that M represents male, F represents female, R right-handed, L left-handed. Great. Okay, so we now know the terminology. So they want us to find out the probability of being male. So it would probably make sense to take a second and total up the rows and columns here. So let me do that really fast. So the total of males that are right-handed and left-handed are 52. And females would be 48. The total for the right-handed people, which, oh, sorry, by the way, that totals up to 100, which makes sense because we're told that there was 100 people asked. Okay, so for right-handed people, 43, 44, that's 87. And left-handed people is 13. And those two add up to 100 also. Okay, great. So now that we got that information, let's find the probability that somebody is a male. So because males are being counted in both the right-handed and left-handed categories, we'll use the total of 52 out of 100. And since this is kind of all out of 100 like that, I'm going to write definitely the decimal. I'm not even going to bother writing the reduced fraction. It just makes sense to think of it as a decimal. So 0.52. All right, for females, we're looking at 48 out of 100 or 0.48. Right-handed people, that would be 87 out of 100 or 0.87. Left-handed people, 13 out of 100 or 0.13. Okay, so that's nice. Not too terrible here. Okay, so now they want to know the probability of being male and right-handed. So now we're looking at the group of people who are both male and right-handed. Well, that would be these 43 males that are right-handed. So 0.43. Zoom out again, just so I can keep that table on my screen here. Okay, female and left-handed. So looking at females that are left-handed, that would be those 4 females out of 100, which is 0.04. Male or female. Okay, so different, right? Male or female. So for male or female, we're saying that, well, that's everybody because they're all falling into those 2 categories for these 100 people. All right. So that would be 100 out of 100 or 1. Male or right-handed. Okay, so we're looking that they could be male or they could be right-handed. Now, there are 52 males and 87 right-handed people. But the problem is that in that number, there are 43 people being counted twice. So if you add those 2 together, you would need to take out, so if you add 87 and 52, you'll get a number bigger than 100, which wouldn't work, right? Can't be, a probability can't be bigger than 100. You would need to take out the fact that 43 was counted twice. So the easiest way to be doing that is just to do the 43 plus 9 plus 44, the other right-handed people who are female. So that totals up to 96. And we could say 96 out of 100 then, which is 0.96. I'll squeeze that in over here. Okay, so we're going to use that same logic for the next one. Female or left-handed. So people who are female, there's 48. People who are left-handed, there's 13, but there's 4 females being counted in both of those categories. So let's add up the two numbers that come from females, which would be the 44 plus 4, and then the 9 males who are left-handed that would also qualify in this group. And that comes out to 57 or 0.57. Oops, which I wrote backwards. All right. Okay, so this is asking for male complement. So all the people who are not male, well, that would be female. So that's going to be 48 out of 100. And this is in this group of people who've answered. Okay. All right, now we're getting to the given, the conditionals. So these are when we're going to limit, instead of going out of 100, we're going to go out of the group they're limiting us to. So when they say, what is the probability that somebody is right-handed given that they are male? That's what part K says. Right-handed given that they are male. That means we're looking at the males and we want to know how many of them are right-handed. Well, that would be 43 out of 52. And that is, let's go ahead and go to 0.83, rounding that number to 0.83. So I put that in the calculator, I'll just round it. You could go further than that if you really want to. You could round to 0.827, but this is fine. This is good. I'll just be consistent with the fact that I've been doing 2 decimals the whole time. All right, female given left-handed. So we're looking at the left-handed people now. So this is limiting the group we're looking at. We're looking at only left-handed people now. And out of those, how many are female? That would be 4 out of 13. And that rounds to 0.31 when you put that in the calculator. Okay, now this is the opposite of part L. So now instead of limiting ourselves to left-handed people, we're going to limit ourselves to the females. So we're looking at the group of females here, and we're saying how many of those females are left-handed. So out of the females, which are the 48, 4 are left-handed. So this is 4 now out of 48. So now we're looking at the entire group of females. And that is going to be 0.08 if I'm just staying consistent and rounding to 2 decimal places.